All right, your review video for 1.8, valence electrons and ionic compounds. So we want you to explain the relationship between trends in the reactivity of the elements and periodicity. So you're trying to figure out the two key ideas here are the number of valence electrons. That's something we talked about in first year chem. You need to have that memorized as you go across the periodic table, how many valence electrons an atom has, because that is going to determine the reactivity. Reactivity is, well, what chemical compounds is it going to be able to form? Will it act as an ion? When it does act as an ion, what charge is it going to form? And that's the second thing, is that you need to figure out what charge things are going to form. One of the key ideas is right here, elements in the same column on the periodic table. Again, columns go up and down. So everything in the same column has the same number of valence electrons, has the same charge, and they tend to form analogous compounds, which means if you know the ratio of one compound, you can assume that everything else below it will form the same ratio and have similar properties to it. All right, so let's quickly review valence electrons. These are the numbers. All right, so valence electrons, they are the number of electrons in the outer shell. And we are going to use this quite a bit for Lewis dot structures, and also we can figure out charges on ions because of this. So it goes, first column has one valence electron, then two, and then we'll jump over the D block. They all have two valence electrons. We don't work with them very often. We ever really ask you the number of valence electrons there, and then 3, 4, 5, 6, 7, 8. Pretty straightforward. You need to be able to, if I say, okay, how many valence electrons does SE have, you need to be able to tell me, you should be able to come up with that number really quickly. Okay, ionic charges. All right, so again, everything in the same column has the same number of valence electrons. We also find that there are certain structures, mainly the structures of the noble gases, that are the most stable structures. When the valence electron is full, that is when atoms or ions exist. We have studied this in nature. Turns out that's what happens. So you need to know the type of charge they're going to form. All right, so we've got first group is all plus ones. Second group is all plus twos. Again, these are typical charges. And then we've got plus 3, although I'm going to add in. So here's your, the staircase is going to be important here, because you want to remember that we have over here, we have the metals, and these are going to be the positively charged ones, and then we have the nonmetals, which are negatively charged. So these numbers only extend down to that staircase. So even though something like SB, antimony, is in that -3 row, because it's a metal, it's not going to be a -3, it's going to be a positively charged ion. So. But other than that, those are the ones you need to know. Let me get my eraser here. Yeah, and then you'll notice I left a gap here. There's no plus or minus 4 for that row. So carbon, it has 4 valence electrons. It is not, we don't see carbon forming ions. Carbon will share those electrons. So that's why there's no number there. Also no number over here, because those tend to form, if they're going to bond at all, which they only start bonding when you get down to Kr, I believe. If they're going to bond at all, it'll be covalent as well. They will not be ionic. Okay, so practice 1, here we go. Okay, so so here's what happens with AP Chem, different than Chem. So first year Chem, we would say, hey, what charge does calcium form? And you'd say, oh, +2, done, move on. Nope, now we're going to layer things on top. That's what makes it Varsity Chem. So now we're going to ask you to combine electron configurations and your knowledge of the charges. So element X has the electron configuration above. What is the formula for the compound formed between element X and chlorine? Okay, so first of all, you have to look at this and figure out the charge that element X is going to form. All right, you might recognize, oh, I can look at the periodic table, this is aluminum. Okay, true. It didn't ask me to identify what the element is. I can still call it element X. What I do need to recognize is where it is on the periodic table. It has 3 valence electrons, which means this is going to form a +3 ion. Chlorine, looking at where chlorine is on the periodic table, chlorine is going to form a -1. All right, so now you've got to go back, and this is where a lot of times in first year chem, a lot of students struggle. You need to quickly be able to look at these charges and recognize, okay, what compound are these going to form? The key thing, the principle you need to go back to is ionic compounds are neutral. All right, so if I have an Al3 plus and I have a Cl minus, it can't just be a ratio of, or sorry, I need to go with an X here to keep it consistent. It's not just going to be XCl. That is not going to be the compound because those don't balance out. What I'm going to get is XCl3. It's going to be a 1 to 3 because if I have a 3 plus, the only way I get this to balance out is if there are 3 negative 1s. All right, so this, I need a total of 3 minus to be able to balance that out. So that's something you need to be able to do. Again, really the ones you're working with for our main group elements, you could either have a 1 to 1. So let's say you had a negative 1 and a plus 1. You could have a 2 to 1 or a 1 to 2. Let's say you had a negative 2 charge and then a plus 1 charge. And so you're going to have, this would be like XY2. This would be like XY. You could have 3 to 1. You could also have 3 to 2, or 2 to 3, 1 to 3, or 1 to 2. Those are really your only options. And so really the shortcut we've taught you is that you just take the charges and you crisscross them. And that works really well. So yeah. Okay, so here is kind of thinking through. So again, you recognize that element X, where it is that third, or in the 3 plus column. And so your answers could be XCl3 or AlCl3. I think both would be acceptable. All right, practice 2. A student claims that a compound with sodium and fluorine and a compound with sodium and oxygen will have the same formula. And of course, same formula doesn't mean that the actual letters or atomic symbols are the same. It's really talking about the ratio, that they are both the same ratio. Do you agree? Explain why or why not. Okay, so first of all, make sure, this is kind of an example of an FRQ question that you're going to be getting. When it says, do you agree, you as part of your answer, and these are really only worth 1 or 2 points, sometimes just 1 point, you actually have to say, yes, I agree, or no, I don't agree. You have to get your claim in there somewhere, otherwise you are not fully answering the questions. And then explain why or why not. And so whenever it says the word explain, you need to start getting at the structure of the why, like what causes these to be the same ratio or not be the same ratio. So we're always going into the scientific principles. Okay, so let's think about what we know. Okay, they both have sodium. Sodium is a +1 charge ion. All right, now fluorine on the periodic table is a -1. Oxygen is a -2. All right, so will they form the same ratio? No, they will not. And then explain why or why not. And you're getting at the evidence is the charges that they're going to form. So you should say no, I disagree. Sodium ion has a charge of +1, fluoride a charge of -1, oxide a charge of -2. So really, you're presenting your evidence there. Again, can't just be brilliant, you have to communicate brilliant, you have to explain your thinking. So the formula when Na and F bond will be NaF, sodium and oxygen will form Na2O. So again, you can't just stop. You notice you couldn't just stop here. You can't just give the evidence, you have to show that, okay, well, I fully know how to explain this. And so that's something that you'll hopefully start to pick up as we go through more and more practice, that sometimes you have to say that one more thing to kind of reason through or really justify why this evidence matters. And you're going to hear me use the word justify quite a bit, reason quite a bit, why does this matter quite a bit, as you're starting to understand how thorough you need to be in answering the questions. And that is your review for 1.8. That's all of 1.8. There will not be any direct instruction. You are all set to go.